In this video, we are going to talk about measures of spread, and we're going to see the range, the standard deviation, and the variance. So when we talk about the range, we're talking about the biggest value minus the smallest value. Because I'm using those extreme values, this range value is going to be super sensitive to outliers. So let's look at an example. Let's say we have this data set 1, 2, 2, 3, and 12, and we want to find the range. Okay, first thing you notice is that 12 is pretty far away from all the other values, so that guy would be considered an outlier. That range would be the biggest minus the smallest, which would give us an 11 in this case. The standard deviation is really just that, is an average of all the deviations away from the mean. So what is a deviation? A deviation takes that value and it subtracts the mean. So I could take all of those and I could average them together, and that would be what the standard deviation is. It's a measure of that. Now, to find the standard deviation, we usually talk about finding the variance first, and we'll talk about that in just a second. Standard deviation is always going to be a positive number, though, and it has to do with the way that formula is set up. If all of the numbers are the same, so if we just had 1, 1, 1, 1, 1 in this set, then there's no deviation from the mean. The mean of that would be 1, and the standard deviation would be 0. And in fact, the range would be 0 also. The standard deviation does increase as the deviations increase. And the standard deviation is actually called a bias estimator for a population. So if we take a sample standard deviation and we compare it to its population standard deviation, they're not going to be the same. We say it's unbiased if they're the same, which means that that sample statistic targets that population statistic. So a proportion would be an unbiased estimator. A mean is an unbiased estimator. But it turns out the standard deviation is not um, an unbiased estimator. It actually has some bias in there. Now, it's not terrible. We can do some tweaking to make it usable for us, and we'll talk about that later in the course. So let's look at what would that formula look like. So the notation for the standard deviation. If we're talking about the population standard deviation, you're going to see this Greek letter sigma. It kind of looks like a circle with a line connected to it. If we're talking about the sample standard deviation, you're going to see S. And it's a lowercase s, and I'm going to use a cursive S. That way we can tell the difference between that and a 5. Mine tend to look the same. So I told you this was tied to a variance. So the population variance is actually sigma squared. So you can see the relationship between the standard deviation and the variance just by comparing the symbols. The standard deviation is the population variance squared, and then the sample standard deviation is going to be S squared. So what does my formula look like? So for the standard deviation, I've got two options. I can use this one. This is your definition formula. X minus x bar squared over n minus 1. So I'm taking each value, I'm subtracting the mean, and then I'm going to square all of those. So now when I square something, it becomes positive, and I'm adding a bunch of positive numbers together, and then I'm dividing that by n minus 1. So this is the standard deviation. Now, if I wanted the variance, usually it's easier to think about the variance first. I square both sides. So it's going to look like this. So to get the standard deviation from the variance, all I do is I take the square root of it. So that's why I have the square root there. always a positive number. So there's your definition based on, a formula based on the definition. This is the computational one. This one I think is a little bit easier to use. So it's n times the sum of the x squareds minus the sum of the x's quantity squared divided by n times n minus 1. And if I wanted the variance, it would just be the square of that. Oops. And we talked about this notation for the sample variance earlier. Um, what's interesting with this is that the sample variance is unbiased, but the sample standard deviation is biased. And we'll dive into this a little bit more later in the course, but just keep that in mind right now. It's pretty interesting to think about. We talked about the formulas earlier. I'll just put above here. One thing I do want you to know is the relationship between them. To find the variance, I take the standard deviation and I square it. Or I could say the standard deviation is equal to the square root of the variance. So make sure you understand those relationships. Now, let's look at an example. So let's say we have a data set that consists of these numbers 1, 2, 2, 3, and 12. And we want to find that standard deviation. So my standard deviation formula is the square root of the sum of x minus x bar squared over n minus 1, or we could use s equals square root n, sum of the x squareds minus the sum of the x's quantity squared over n times n minus 1. I'm going to show you how to use both formulas. So for this one, first thing we have to do is figure out what the mean is. So for the mean, we're going to add them all up. And then we're going to divide by how many numbers we have. We have a total of 5. So we have 12, 15, 17, 18, 19, 20. And 20 over 5 is 4. So this formula says I'm going to take each x and I'm going to subtract the mean. And then I'm going to take that number and I'm going to square it. So I'm going to take x, subtract 4. 1 minus 4 is a negative 3. 2 minus 4 is a negative 2. 2 minus 4 again because I have two 2's. 3 minus 4. And 12 minus 4. And then I'm going to take each of those and I'm going to square it. So negative 3 squared is negative 3 times negative 3, which is 9. Negative 2 squared is negative 2 times negative 2, which is 4. Negative 1 squared is negative 1 times negative 1, which is 1. 8 squared is 64. So this notation means I need to add all of those numbers together. So if I add 64 plus 1 plus 4 plus 4 plus 9, yeah, 82. So my standard deviation would be the square root of that sum, which is 82, over n minus 1. So I got 5 minus 1, which is 4. So 82 divided by 4 is 20.5. and whatever the square root of 20.5 is. I'm using my calculator over to the side. It's about 4.53. So I'd say my standard deviation is 4.53. My variance would be the 20.5. It's that stuff under the radical. Now, if I use the other formula, I think this one's actually a lot nicer. Remember, n is 5 here because that's how many numbers we had. So I'm going to create an x column and an x squared column because I need to sum of the x's and I need to sum of the x squareds. So my x's are my numbers 1, 2, 2, 3, and 12. If I take each of those and square it, that's what's going to go in this column. 144 goes there. So now let's find the sum of the x's and the sum of the x squareds. So if I add up this column, this is going to give me 20. If I add this column, I get 162. So my formula, S, says I'm going to take the square root of n times the sum of the x squareds, which is the 162, minus the sum of the x's, which is 20, but I'm going to square that number. And I'm going to divide by 5 times 5 minus 1. Now I'm just going to work on that inside. So 5 times 162 minus 20 squared is 410 divided by 20. And that's going to give me the square root of 20.5. So S is square root of that, which is 4.53. And that's the same thing we had up here. And my standard my variance, when we fix my notation there, is the 20.5, because it would be the stuff under the radical before I take the square root. So you can see either formula is going to give you the same answer. So you've got some options as to which one you're going to use.